Welcome to Rudy's Electronics Lab. And I'm super excited that I now have a Rode and Swart CMW500 telecom tester here. This is a device I already wanted for a while. I've kind of saw the offering of this device growing on the internet, and recently I decided to make the final purchase because this is a device that's a bit in the tradition of the CMW100, a very popular instrument for radio amateur, for people in test and measurement, because it got like a lots of generic type of functionalities apart from its original the reason it was designed for. And I'm interested if the CMW is a worthy successor and whether it is similar or even better as a generic type of instrument. So I'm going to do a whole series of episodes on that, like I did with the CMU in the past, and we're going to explore all these different things. But in this first episode, I basically first want to focus on what exactly is the CMW500 like? What was it designed for? What you can do with it otherwise? What are all the different versions? What are all the different options there? Also discussing these type of aspects that are relevant for a buying process of the CMW. And in later episodes, we're going to separately dig into the use as a spectrum analyzer, the use as an RF signal generator, as a power meter. I think I'm going to do a separate episode on the internal hardware. That will still come. But today focusing on what is it and all the different options. So I think the best way to describe this device is a very advanced piece of kit. And it better be for the price that it was selling for. We got a telecom measurement device that is up to 6 gig frequency range, up to 160 megahertz real-time type of bandwidth, and originally built for system design, product design, and production testing for mobile phones and other telecommunication devices. So for this, it basically supports a whole range of different cellular protocols. And I'm showing a number of protocols right now that are supported by the CMW. And not going to only like measure modules or whatever, but it can basically do a full network emulation there. So the full signaling. So the CMW can basically act as a full network, as a base station, set up a call with a mobile, test all its functionalities. And then we also got a whole list of non-cellular telecommunication functionality that is support, including Bluetooth and Wi-Fi and satellite navigation and so on and so forth. So an incredible support of protocols, very precisely implemented because it's a bit of a reference device there. And it also got like very advanced features in these protocols. So it got support for multiple in, multiple out MIMO. It got support for carrier aggregation in 5G systems. It got multi-red signaling over different networks. It supports scenarios like offloading mobile traffic to Wi-Fi. And it can simultaneously emulate up to 4 of the same radio network or different radio network for kind of, yeah, when your mobile phone is transferred from the one type of network to the other, like handover. And it also does it very accurately. That was important in the type of setting that it was designed for. These devices were often used in production lines, and there you usually would have a contract to your buyer, whether that is Verizon or Vodafone or Apple, that everything that you ship meets regulatory requirements. Each individual unit must be tested. You must make sure that's in the regulatory requirement, but at the same time, you don't want to trash any of these units that are still slightly within the limits that don't need to be trashed. So you want to be very exactly to make the difference between them, to keep your yield at a high level and respect your contract. So in that sense, the accuracy of these devices is much better than you perhaps might expect for a production tester. But of course, we are not interested in what it could do for telecom testing. Well, some people are, and also I am, honestly. But I think must be interesting for this audience is its generic test and measurement function. Because it got an RF signal generator, can do complex type of signal, vectors and IQ. And it got an arbitrary waveform memory of 1 gig or 4 gig. That is fairly generous. Got a spectrum analyzer, both a traditional suite spectrum analyzer and an FFT spectrum analyzer. And the latter one has a real-time bandwidth of 40 or even 160 megahertz of complex signals in the FFT range. We got an RF power meter, got an internal sensor, can also use an external sensor. You can do things like frequency list that you're testing the power for, all type of statistics you can do, there are filters, there are triggers. And for example, you got an IQ recorder where you can record complex IQ streams basically to a disk, like the values coming by for later type of analysis. Now, it's this type of stuff that I think that makes the CMW interesting for a wider audience as a second-hand type of instrument. Now, there are a couple of predecessors, all history to this type of machines. And there are at least 4 generations here. There are even some older devices, but these are the generations that are made like in higher volumes and came on the generic market. There's the CTS family of tester devices. Actually, I never have touched any of these. Then there was a CMD family of devices from about the late 1990s on. And actually, there's one right over here. It's up and working. It's in a good condition. I managed to do some testing of 2G phones with it. But unfortunately, there's no generic functionality at all, except that it can measure voltage and power, etc. But this is kind of useful for any generic type of measurement because it only supports very narrow frequency bands used for these standards. And its measurements are always in the context of these devices, not generic. But then we have the CMW from the early 2000s, the 200, the 300, the CTRU, if I say that well. And these became very popular because of all these generic functionalities they had and the continuous frequency band from very low up to 3 gigahertz. And now we're then looking at the CMW, the 4G device here basically had so 2G, 2 and 3G, 2, 3 and 4G basically. And that also has like, yeah, similar type of, but not identical test and measurement functionality as the CMU200. Now the CMU500 is actually, there's not one single device, there's a whole family. And the CMU500 as I have it here is their high-end model. Then there are a couple of more cost-effective models, the 280 later replaced by the 290. It's a bit more compact, it's a little bit less deep, and I think that also means you can have less extension boards in there in terms of number of channels or hardware support for protocols. And you also got the 270 tester, and that was designed for non-cellular type of application like a Bluetooth tester or a WiMAX tester. WiMAX was never that popular, but I see quite a lot of them on the second-hand market, maybe because WiMAX was not popular. And there's more recent additions to the CMW family is the CMW500. It is one that can measure, I think, up to 8 mobile devices at one time. That's an advantage in a test production environment, no, not a test, a production environment where the CMU500 can only do 2 phones at a time. This one can do 8 at a time. And then the interesting thing comes, there's the new platform, the CMX platform. That's a 5G platform by Rode and Swart. But look at the picture. You see the CMW, which I have over here, together with the 5G platform. And why is that so? I think that is so because in their new platform, the CMX500, Rode and Swart designed to make that a 5G only platform. So you can only use like standalone 5G modes, networks and phones that will be only 5G. But in reality, kind of all the networks and all the phones implement 5, 4, 3 and kind of constantly switching between them. Even stronger, the most common scenario with a mobile phone is that the mobile phone is continuously connected to 4G, which we would call as anchor, and only switch to 5G for a particular data transfer session if that is available, and not tries to keep continuous connectivity in 5G. So you need them both. And so Rode and Swart did not implement that in their new series, but kind of assumes that the customer buys both the older series, the CMX series, the CMW series and the CMX series, and they work together in tandem. There's an Ethernet connected between the two of them. It's all integrated, so you really need to buy them both if you want to do anything in 5G. Which is also the reason why the CMW500 is still currently in the Rode and Swart catalog. And they're still adding functionalities. Even over the last couple of years, they added things like LTE anchoring, they added like voice over new radio, they added like Internet of Things protocol and narrowband type of communication protocols. And so you can still buy them brand new, and the list prices, what I saw on the internet, went all the way up to $260,000. And actually that's even far from a fully populated device. I think if you would fully populate with all the hardware and software options, you would get way above $300,000, maybe $400,000 for a fully loaded CMW500. That is a lot of money, But apparently clients were happy to pay for it because they sold thousands and thousands of these units. Now, if you would now buy them secondhand and you will buy them from a reputable type of dealer with full warranty and support and everything, I think you can expect prices, or at least I saw prices that are like 10 times lower than the original list price. But I think for a lot of amateurs and home use, that's still very expensive, several tens of thousands of euros. Now, where it gets interesting is that right now we see these devices becoming also on the market basically on auction websites, etc. And there actually we see sites popping up now with dozens of units on sale and with prices that are 100 of the original price. So we're talking about 1.5, 2 or 3K for a working CMW500 depending on its condition. And why this is happening right now, I think this is because like all the production facilities that like bought all these units in the last decade or so, now all switched to making 5G phones, so they need 5G testing equipment, and they're basically retiring their 4G testing equipment, including all these CMW 500s. So there are already a lot of them being offered right now, and I think the offer will only increase, what I understand, which also might bring prices further down. And suddenly, I think, bring it in reach of a lot of amateurs that could kind of consider this as an alternative to other choices when it comes to the RF domain. Now, I want to focus on if you would like to buy a CMW. You have to take a couple of things into consideration. First of all, what is type of the appearance of the device? Does it need to have a display and a keyboard in it? Second of all, like all the different functionalities in hardware and software. And thirdly, a number of general performance options that probably want to think about when you're going to buy one. Before I can go into all these different choices that you have to make, we have to look at the source of all this information. And basically there are a lot of different documents that I was able to find of this. The thing is that it's not always easy to find these documents. I'm still missing a couple of them. It's not always fully consistent across the documents. They're rather complex and long, and sometimes been running into some inaccuracies as well. And I think also one of the challenges is that this covers like 50 years of time or more. So some documentation relates to much more recent versions than other type of documentations. But if anything, if you're interested in it, I would advise you to start looking at the very first document here, which is called RF Production Testing Product Brochure, because that is a good description of all options and general setup, etc. Even more so than the datasheet document, but in the end you probably want to get all these documents. This also brings me to a disclaimer. What I'm going to tell you now about all these different hardware and software options, this is based on my best knowledge, but there might be mistakes. It is very complex and sometimes it is contradictory in the documents. Also, most of my documents relate up to firmware version 3.7, so it might not cover later firmware version that came after that. I'm also running, I think, 3.7 on my device here. First of all, which type of box are you getting? Are you getting a box with a keyboard and a screen or without it? The version with the keyboard and a screen does not have a video output as a standard. It comes as an option only. If you get the box without the built-in screen and keyboard, then obviously you have a video output, a DVI output, and it's right away on the front side of the device. And now we're getting there. All the options and licenses. There are hundreds and hundreds of hardware options and software licenses that you can choose on this device, making it pretty complex. And in many of these hardware options, you can also choose twice if you want like a dual channel configuration device, and then you also need to license all of this software twice if you need it for that. So it gets like in a very complex setting. They all got kind of codes for it, and I've been trying to figure out a little bit of the meaning of these codes, and I believe like there are a couple of categories of hardware codes. There's PS are the assembly codes, there's the S, that's the front panel version that I'll just be talking about, and then all the plug-in modules are called B modules, like B200. Now, they're called like that in the documentation, but actually if you go to the configuration device, all of them I think are indicated with the letter H instead of a B, but I think that's fully equivalent. And we got some hardware options that are called also KB. I'm getting to that later. And then we got all these licenses and software options, and here you see kind of the codes used. I'm not going to talk through each of them at the same time. And To make things even a little bit more complex, whether you need a license for something can depend on your firmware version. Sometimes in older firmware versions something required a license, and in the latest firmware version there became a standard functionality there. So I'll show you actually an example of that in a moment. Now don't get discouraged. Now I'm going to look at all these different software options. I start with the device as a telecom tester, because that was originally designed for. And don't get shocked. This is 2G and 3G. Here you see all the hardware, the third column, all the software options, all the other columns basically, to do the various type of 2G and 3G protocols. There's stuff there basically for the network emulation that I talk about, acting as a base station. There's stuff for measurement, for generating waveform, for automation, for fading, and all of these are software options that you can add to the device. Often there were updates if you get like new 3GPP releases for particular mobile standards, if you got new functionality like MIMO or carrier aggregation, etc. There were new options developed by Rode and Schwarz and made available as licenses to test all that type of stuff. We're not done. Here you got everything for 4G, for narrowband IoT and mobile WiMAX. So a lot of more standard. I tried to figure out, cost me quite a lot of time to figure out. Everything you see in yellow here, by the way, is present on my device as hardware or as software. Everything in white is not present in my device. Then there's Bluetooth, Wi-Fi, WiMAX, many more options. There's satellite navigation, video broadcasting stuff, radio, other types of waveform functionalities. We're still not done. And we got all this type of automation and test type of stuff. Now don't get discouraged, because if you want to use this device as a generic measurement instrument, actually the world is much simpler. I'm going to present that to you now. This is, I think, the only thing what you need to look at if you want to use this as a generic instrument. For the RF spectrum analyzer, the hardware is already everything standard. You need software option KM10. For the FFT spectrum analyzer, separate implementation there. The hardware is standard. The software is also a standard, at least if you have firmware version 3.0.10. Before that you needed the KM010 option, but you wanted that anyway, I would say. We got the generic RF signal generator, hardware and software is always as a standard. We got the arbitrary pair to the RF signal generator. Then you need a hardware module that has that functionality into it. In one video I'm going to take a separate look at the actual board there. And that's also where the memory resides for that arbitrary waveform. This is something you might want to consider for having included in your unit. Internal power meter comes as a standard. External power meter, you of course need the external sensor. And if you want to do the audio analyzer functionality, you need a specific piece of hardware. The software comes as a standard. The piece of hardware that you need for the audio analysis, the B400B, I haven't seen it that much at all in the offerings. And I think it was very rare and probably not in many of the production testers. So it might be very hard to find, and it might be actually expensive. So you have to figure if it's really worthwhile to go after that. The other options, I think, is kind of worthwhile to do it. And again, everything here in yellow, I got it in the unit right over here. Yeah, for the price that I already mentioned, less than 3K. Other performance considerations. I think you certainly want to think about the other things, whether you want them or not. First of all, the 6 GHz frequency range is a hardware option, and it doubles the frequency range for everything. Spectrum analyzer, signal generator, power meter, whatever. There's the 160 MHz bandwidth option, so that's a real-time bandwidth that is digitalized in the device. You see here the hardware option that comes with it. If you don't have that, then your receiver functionality is 40 MHz and your transmitter functionality is 80 MHz. And if you take this option, everything is lifted up to 160. There is a dual tester configuration. Everything is double inside. You can test 2 mobile phones at the same time. For generic test and measurement purposes, I don't think that makes a lot of sense to spend your money on that. And the last thing is the type of CPU for the user interface. Now, I cannot find anything in the documentation about this, but I have learned that there were different versions of it. A 1.5 gig processor, a 2.2 gig processor, and also a faster one. And the faster one is actually required, I believe, if you want the 160 megahertz digital bandwidth option. I got a 2.2 gig version, but yeah, something that you might want to take into consideration. Now, coming to the end of this episode, is it worth buying a CMW? And in later episodes, I'm going into each of these functionalities and how they compare to other devices, but more from a overall level. What are the advantages? Yeah, there's this wide range of test and measurement functionalities, very nicely implemented. It's a top of the range device. It is very, very professional. It got like an impeccable build quality, and there's also the whole history and the heritage that comes with this type of devices. It fascinates me. But there are also disadvantages, obviously. The purchasing process can be fairly complex with all these different options in hardware and software. You want to communicate with the seller to make sure what you're getting is working, and what the seller will do is there was something wrong with the device. I actually had something wrong with the device, and fortunately my seller was very helpful, sent me a new unit or a new card, and I installed it and everything worked again. But well, it's certainly more complex than buying a new device or so. Finding all the documentation and getting through it can sometimes be a bit challenging on this device. That's also a bit of the part of the puzzle, I would say. And then also, depending on the age of the device, units could start to fill over time. Many of these devices will have run many hours. Actually, I wasn't able to find yet any counter. I know them in my other devices. I haven't been able to figure out how many hours it has been uptime. Maybe it's somewhere in there. If you got a more modern unit and or a unit with an SSD instead of a hard disk, like mine, actually it came with an SSD, then you might have a little bit less concerns over that. And I think a disadvantage is that there is no extensive amateur community on this device yet. There is one for the CMU. There's so many people that have been working on it, repairing it, writing software for it, sharing experience with it, etc. There's not much on that on the CMW, but not yet, I would say, because I think they will flood the market, and they are super interesting instruments. So I hope this community will kind of be created, and I hope this set of videos that I'm making is kind of a first step into creating such a community. And that brings me to the end of the video. Like I said, there are going to be separate episodes. An episode for using it as a spectrum analyzer, an episode for the signal generator functionality, for the power meter. I think we're going to do an episode where we're going to open it and get like all the different hardware and investigate it a little bit, etc. So stay tuned for that. I hope you found this an informative episode, and hope to see you soon back at Rudy's Electronics Lab.